Ah, there is a workbench. So, there is a workbench top. I think I've got everything, at least in this area, is pretty much like it's going to stay now. I was going to do separate, unboxing videos and whatnot. There's really no need for me to go over, do whole walkthroughs on each piece of test equipment. So there's 3 new pieces here. That one, and that one. The 3 new pieces of Rigel equipment. The bottom one down here, the spectrum analyzer, I've had that. Yeah, I've been saving up for all this shit for quite some time. It was one of those, I'll get one, I'll just get all 3 of them at the same time, because I'm going to redo the workbench. I don't want to get a piece of equipment, redesign everything. Get another piece of equipment, I have to set everything back up again. Now, the first thing I did was, I had these 3 just sitting on top of each other. Yeah, that wasn't working. It wobbled. If there's one thing that really sucks about new equipment, and I guess that really depends on your point of view. For the average person, the new test equipment's fantastic because it's so small. Now, I don't mind the width. That's fine. Matter of fact, the smaller the frontal area, the better. It takes up less, less cubic area on, the workbench. So, the smaller I can get stuff this direction, the better. But I actually I'm really, really starting to dislike the depth of modern equipment. It's so stinking shallow. All 3 of these pieces of equipment here, they're like that deep. I mean, just a couple inches deep. And you cannot stack stuff on top of each other with any stability. So I had and what we have here is a new digital multimeter, 2-channel signal generator, and a oscilloscope. I'll go over the options because I got a lot of options as well when I got them. But I had all 3 of these stacked on top of each other. And yeah, you just bumped it and it kind of rocked back and forth. It wasn't going to fall over because you could actually push it rather far and it would kind of whoop, it would just rock back and forth. And I was like, yeah, this ain't going to work. So now I had actually started a video, stopped, because the more I looked at it, I was like, yeah, I got to do something. This Leaning Tower of Pisa, yeah, I can't have that kind of shit. I was going to make the shelf later, but I couldn't, there was no waiting. So, as you can see, there's a new custom shelving unit, and you can tell, yeah, it's definitely custom, because you're not going to go to the store and buy one that has, that's built to fit, specifically around a BK2040, CB signal generator. So, took some measurements and just quick went out in the wood shop, fired up the table saw. I was thinking originally, when I do the shelf, I was going to get fancy, because, man, it's been so long since I made a piece of furniture or anything fancy. And I really do like doing woodworking, but God, I don't know if I've fired up the table saw in a year. I just don't get time to do anything like that anymore. So, I was thinking, man, I was going to do dovetailed shelving, be really fancy. I was going to do it out of either probably cherry or mahogany. Out of hell with it. I just grabbed a piece of 4-inch thick pine, ran it down the bandsaw, thinned it up down to 3/4 inch stock, ran it through, well, actually inch stock, and then ran it through the planer and joiner. So, basically down to, nominal dimensions for 1x8 lumber, and just made some shelves. So, and it's just pocket screwed together, because that's fast. Like I said, I could have done dados, I could have done dovetails. There's a million different ways I could have gone. Honest to God, I just fire up the Craig Foreman. I'm sure some of you have seen the Craig pocket screw jigs, the little like hairy homeowner pocket hole jigs. Well, I have one of the big Foremans. It's a big piece of machinery. It's self-powered. I use that when I'm building cabinets and a lot of furniture. But back when I used to, when I had time for that kind of stuff. But yeah, it makes really fun. I mean, it took me all of a minute and a half to drill out all the pocket holes. There was 4 pocket holes at every intersection. There's 4 pocket holes, screws. screw holes you drilled in. But yeah, it's not going anywhere. It is rock solid now. I mean, rest of the building could collapse around and that thing will probably still be standing there. It's one thing I really like about pocket hole joinery. It's, man, it is strong. But so, like I say, it's together now. It's going to be a work in progress. Anytime I redo the bench, and I've already had to redo. Like I say, I started the video, and the more I got to look, I was like, man, this just ain't going to work. So even before I got the video done, I had to. I've already redesigned again by adding the shelf. I had some different equipment over here, and that was a problem. Was the way I had stuff, because I was left with this little narrow area right here, and I couldn't really stack anything there. And I like going up with my shit, as take full advantage of every square inch I can use. Space is precious here on the bench. So, I built this shelf so I could overhang the BK2040 as far as I could, leaving the stereo amplifier analyzer over there. And that allowed me to stick my vacuum tube voltmeter over here, because I have to have that. Work on tube equipment. Actually, I guess I really don't now, which I'll get into that with this piece of equipment, the multimeter. But vacuum tube voltmeters, you can't beat them. And a lot of times you have to have those because of the input impedance. When you're working on radios, you have to watch, like when you use Sam's manuals, they'll list measurements for at all the tubes, or even in solid state. But you also have to look down at the legend, because it will tell you at what impedance, what was the meter impedance that was used to take that measurement, because the input impedance can greatly affect the measurements as well. So it might say 5 volts on the schematic was the test measurement, but that was however many volts with a 10 mega ohm input impedance. You go sticking a 1 mega ohm input impedance on there, it might be off by a volt or two, or 10 or 100, depending what voltage level you're measuring. Or if you go using something with 100 mega ohm input impedance, it could, like I say, it can drastically affect it, because it loads the circuit. It's how it loads down the circuit. But so I had to have that. No ifs, ands, or buts. That had to get back on the bench right now. There's some other stuff that's not here. It's got to come back at some point in time. But so I guess we'll start on the left over here. So I've kind of whittled down, just for the moment. I removed 2 power supplies. I had a 80 amp laboratory Wayne Kerr switch mode style power supply over here, a really big monster. Honestly, I rarely used it on this bench. There's actually another bench I could use it on more, so it was transferred over to that. But I really don't need an 80 amp one here. 50 amps is fine, so I have the Astron 50 amp down there. That's fine. That's the most I usually need at this bench. This one stayed. That was down here. That just moved up and over, and everything's swiveled around, so it's now actually easier for me to reach over to turn stuff on. I don't have to stand up. I can just reach across the bench now. It's it's not kind of tucked way back here in the corner, facing straight out. But it's easier to get to now. There's another laboratory power supply there that had adjustable constant current, constant voltage settings. That one does 3 amps at up to 60 volts, and then a high voltage old HP 1940s vintage tube type power supply, which I need for doing tube type work. Can't be without my signal tracer. No ifs, ands, or buts. That was another piece that I had to get back on the bench. Now this corner over here, this section's not done yet, because you see there's real estate up here. Yeah, there's blank area. Yeah, well, I don't do blank area. I've got to fill that in. So I've got some laboratory wideband or broadband amplifiers that are going to be going on the bench. You've already seen a video on a Keithley. There's also going to be another one, a 5-watt one, which I'll get into that in a minute, what I'll be using that with. But like I say, so I had to have my signal tracer back. Actually, there's another little tiny power supply. That's just the only thing that gets used for is to power the lights in this light head right here, because I just stuck a bunch of replacement, a bunch of LED bulbs in there, cut out a piece of kind of thick plastic sheeting and stuck them. These are actually LED replacement lights for in a tractor trailer, like 1156s, I think they were. But I just got them soldered on the other side, cut the plastic to fit in there, just kind of shoved it up in there. It works perfect. Great replacement for 120 volt light bulb. But that's the only thing that little guy right there is used for. But like I said, I got those laboratory power supplies are probably going to go over here, so I had to get my bench back in working order, where I could actually work on stuff. I removed the little switch box or power distribution box I had up over here on the right hand side, and I've actually pulled out one of my MFJ outlet distribution boxes here. I've got a couple of those. Stuck that up there because I actually wanted to put one of these up on this bench before, but I really didn't have any room. Well, now I've kind of got a little bit of room because I've removed several pieces of equipment and only some of them are coming back. So I had room to actually stick that in because that's a lot longer than that little homemade box I had up there. Got my microphone audio switching circuits for being able to basically hook up any radio to any possible audio source. Frequency counter. Just a little bench monitor, CB radio. This multimeter stayed, and that one stayed for a reason. I had two of them on this bench before. I had that one and an HP. A lot of people were saying, well, why didn't you stick with the HP? It's a better meter. That was, that also had, did 4-wire resistance measurements. Yeah, it is. It's a better quality meter, but it had, I wouldn't even say 2 drawbacks. Well, no, 3 drawbacks, honestly. It did not use double insulated banana plugs like this new meter uses and that meter uses. So you needed 2 sets of test leads. So if I ever if I want to pull the current lead off of this one and plug it into that one, well, no, I'd have to use an adapter. I got to use one of these adapters that goes from the double insulated down to just a standard banana plug. It's a pain in the butt. So that meter can go over on another bench. But main reasons I kept that one was the HP, and actually this new one as well, they only measure up to 10 amps of current. That one does 20 amps. Kind of a high current reading for a bench multimeter. So that's another reason that stayed. And the third reason is I just like LED displays. I think they're a lot easier on the eyes. Looking at something 18 hours a day, it's a lot easier to look at that nice, very, I don't want to say it's soothing, but not hard on the eyes. And you can see this new meter here. So this is we'll get to the first piece of new test equipment. Well, actually, the bottom piece, of course, communications test set. It didn't move. I don't think it budged a 1/4 inch in any direction. I might have pulled it out or back a little bit, but that was about it. But the digital multimeter here. So this is a DM3058E. It's a 5.5 digit multimeter. Get in here a little bit. Now the first thing you're going to notice, actually let me get this mic cord out of the way. Actually, just the only reason I had that hooked up there was I was testing it out, make sure I had everything hooked back up. This is normally my bench test cord that goes up to my little audio test box. The first thing you're going to notice is you can't see anything. It's being blinded by the intensely bright. It's not intensely bright actually in person, but to the camera, it's just, the bloom, it's just blinding the camera. So I did find a little handy feature in this. I'm really glad they stuck it in there. So if I go into Utility, System, Display, Invert, I can invert. So now you can actually see it. So that's really handy. So anytime I'm doing stuff on camera where I'm going to be filming that meter, I'll have to use the invert screen, but I'm really glad they added that option. Because otherwise, it would be, I'd have to go and change camera settings, and this way I can just turn the camera on, start filming. I don't need to worry about any other adjustments, so it can actually see the, what the meter's displaying. So it does, of course, DC, AC voltage, DC and AC current, ohms. Now this one actually has a capacitance meter in it. It's not an ESR meter, it's not a component analyzer, but it measures capacitance up to, I'd have to pull the spec sheet, but I think it was 10,000 microfarads. So pretty much, for a lot of the radios I work on, that's as big as capacitors would ever possibly usually get in most of the radios I work on. So that's perfectly fine. I've got component analyzers I can do up to, in the just farad range. I think I got the one goes up to 100 farad that thing will measure. But like I say, it's fine if I just want to grab a ceramic cap really quick, it's rubbed off the value. I can just hook it up to this. Don't have to dig out anything. Continuity tester, diode test, frequency. So it takes frequency, or actually it's frequency or period, up to, I think it's a megahertz. So fine if you're doing some low frequency digital stuff or something like that. Sensor, yeah, that's probably, and that's another thing with all this test equipment. Yeah, it's all computer interfaceable. You could spend hours just going over all the crap these things will do. Because I mean, now this one's not too bad, but the other two, yeah, the menu levels get rather deep into some of this shit, and it's going to take me a long time to read up on this, because there's several hundreds of pages. I printed out all the manuals for all three of these. They only come with a quick start guide. You have to go on Rigel's website to download the manuals. I've got hundreds and hundreds of pages. I think the oscilloscope was like just the owner's manual was 170 or something like that. The signal generator was 150 maybe, but yeah, it's just ridiculous. So, but in any case, nice bench multimeter. Not using the probes came with it, because yeah, may look like nice fancy high-end equipment, but it's not high-end. It's Rigel. Now, it's not cheap equipment either. That's the nice thing. Rigel actually makes fairly decent equipment, but at a reasonable price. But their probes, yeah, pretty much anything that comes with a Rigel, I'm never going to use. So yeah, I'm using good fluke test leads on there. So over here we have the signal generator. So this is a DG4102. It's a 2-channel, 100 megahertz, 500 megasamples per second signal generator. So pretty much does everything. You can go into modulation. There's it'll do them all: AM, FM, PM, ASK, FSK, PSK, BPSK, QSK, 3FSK, 4FSK, OSK. So yeah, it does pretty much everything. As you can see on the oscilloscope, I have it in sweep right there, which is a feature I wanted. I've got a sweep generator. It's an old antique Philips, and actually I've got an old, I don't even know what the hell that thing is, cone core, I don't remember, starts with a K. That's the thing's even older. Those things, you need about 3 college degrees and 5 arms to operate, or 5 hands to operate one of those things, because Jesus, God, those things are complicated. But that was back in the day. This thing's easy to get, to get it to output a sweep. I hit the sweep button, start frequency, stop frequency, and how fast I want it to sweep. It could be just that simple. It's really, really fast. I can switch, signal type, so, square wave, ramp, pulse, but, yeah, I got here. Hell, that's because I went to ramp. Or pulse, wasn't it? Threw that off. Sweep. Stop. Of course, I'm learning how to use all of this shit. That's going to take a while. But, like I say, it's... Now, the only thing is, it only goes down to like, 10 millivolts, I think, is the lowest level. So, or was it 100? It might be 100. It's 100 or 10 millivolts, whatever it is. It doesn't really matter. It's too high of an output to be used down in low signal levels and radios. So, I got to dig out one of my good HP rotary attenuators. I'll hook up to that so I can get really low signal levels down at like, in the 130 to 140 dBm range. Like I say, that's easy to handle that with an external attenuator, but it goes up to like 10 volts peak to peak output. So hell, you could hook a speaker up to the damn thing and listen to it. And we come down here. Here. So the next piece is a Rigel DS1104 Z-S Plus. Now it doesn't show the S up here, but it is, and it's very easy to see that it is an S model because it shows source there. There's 2 additional jacks on the back of this. This is also a 2-channel, has a built-in 2-channel signal generator. Now it's only 25 megahertz. But so it was an option you could get with it. I figured I'm going to get it. Just go ahead and get the option. By having that, if I ever need an audio signal maybe or something like that, if I'm using, let's say, the other channels on the signal generator up there at higher frequencies and I need some low-level audio signals or something, I can use the oscilloscope. I can just, turn on the internal signal generator in this, and I've got 2 channels that can do up to 25 megahertz in there. So, I added that option. It also has this LA. If you look down here, there's a big plug on the front of it. This is for a logic analyzer. So now I did not get that. I've got the option, so it's already there, because that's one of those things you need to get when you get the unit. So it's already installed. All I need to do is buy the optional logic probe assembly, the little module with all the the 16 channels of wires that come off of it to hook up. Like I say, I spent enough on this, what I got right here already, so that was one of those things. I can wait on that. It's not like I've got a project sitting here on the bench that I have to have a logic analyzer. So yeah, I've got the option. It's already there. All I got to do is probably within a month or so I'll get the logic analyzer adapter. But this is a 100 megahertz 4-channel oscilloscope. It's 1 gigasample per second. Now that depends though on how many channels you're using. So if you're using 1 channel, it's 1 gigasample per second. If you're using, I think it's 2 channels, it's 500 meg samples per second. If you're using all 4 channels, or 3 or 4 channels, then it drops down to 250 meg samples per second. But for the kind of stuff I'm doing, that sample rate's just fine. And honestly, I'm usually only going to be using one channel. Occasionally, I do like to have several channels. I'm troubleshooting circuits, and I need to see interaction, what's happening from one stage to the next. It's nice to have several channels, to be able to hook up. I mean, I've used up to 6 before. The old scope that I replaced, that old 2-channel, little digital one, I would use the 2 channels in that, and then the 4 channels in this old B&K CRT based one. So, now I have 8 channels. I've got 4 channels there and 4 channels here. Now, the sweep feature. That's one thing with the laboratory wideband amplifier that I'm going to be putting on the bench. That has an output, well, they say 5, but it will do, and even rate it at up to 9 watts of output. So what I want to show is some of these low drive amplifiers, some of the, I don't want to say home built, but even home built ones, some of the old sweep tube amplifiers, some of even the name brand ones like the RM Italy's, but especially the commercially made ones like the RM Italy's, we can actually now test their frequency range. So if the manufacturer says this amplifier will cover 2 megahertz or 5 or 10 megahertz, before, like I said, I really didn't feel like digging out any of those old antique sweep generators I had and doing it with just a communications test set or a normal signal generator that didn't have a sweep mode. You'd have to punch in a frequency and see what it did. Punch in the next frequency. Well, this way you can set it up, like right now it's sweeping from 10 to 20 megahertz. So I can just set the signal generator. Now it will not put out enough power to key one of those little amplifiers, but that's the whole point of the laboratory amplifier. It's a wideband amplifier, good for several hundred megahertz. Covers from basically single-digit hertz up to several hundreds of megahertz. But I can run the output out of this into the laboratory amplifier, and those are also extremely low noise. Those things are like 5 figures in price if you buy them brand new. I got that thing for a steal of a price. It wasn't cheap, but it was a hell of a lot cheaper than 10 grand or more. But what I can do now is I can take this signal generator, hook that up to the laboratory wideband amplifier, set it up to sweep whatever the amplifier manufacturer states is their the bandwidth is for that amplifier, and we can actually test it. So basically, kind of like a setup we have here. we can run the signal generator out, and then we can have, but instead of having the signal generator hooked up to the spectrum analyzer, we can hook up the amplifier under test. And we can actually see, does it drop off? Does it, you know, as you get out toward the band edges, does the power start to drop off? We can check this. Of course, one of the biggest problems you have in a lot of those amplifiers is harmonics, because none of those ever have low pass filters built in. That's why I always tell people always use low pass filters. But yeah, so some more at some point in time, some videos will be coming up. Like I said, I got to get those amplifiers on the bench first, but you know. That was one of the reasons I wanted that signal generator with, like I say, sweep mode. I wanted a more modern one. It just has a lot of, and like I say, I'm going to be reading for months these manuals. I mean, Jesus, God, they're thick. I used a ream and a half of paper, and I'm still actually not done printing it because I want to print out the service manuals. So I'm probably going to need another ream and a half to 2 reams of paper just to print those out. By the time I get done, I should have somewhere between 6 to 8 inch thick stack of paper. But so over here, still have the leader LPM 880 power meter. That's actually a power meter and dummy load. That's good for from 1.8 to 500 megahertz. That's actually a lab grade RF power meter. Really good meter. Of course, the voltmeter, the 1040 and 2040, yeah, they didn't move at all. They stayed. Actually, the stereo power amplifier, it just slid over that way a little bit more so I can gain as much real estate right here, just that little bit right there. But, yeah, and when I say amplifier, I don't mean RF amplifiers. We're talking audio, so, stereo systems. That's what that's meant for analyzing. It has two 250-watt built-in dummy loads in there. The oscilloscope, that moved up there. That's mainly used as a modulation monitor hooked up full-time to the BK1040 there. And same thing with that frequency counter, the 600 megahertz Ballantine frequency counter. It moved up there. It's just hooked up full-time. It never gets unhooked. It's always hooked up to the BK1040. It's just checking transmit frequency. That's its only purpose in life. So, it's coming together. So, like I say, can only spend so much time, with the bench completely dismantled and in a non-usable fashion. So I've got it back somewhat. I can work on radios. I just need to basically work on that corner over here. I might, because I've got the room on top in between those two shelves right there. That bench radio and the little SWR meter it's hooked up, that they might get put side by side and stuck up on top in between there. Now to give me a little bit more room here, because that Keithley amplifier, honestly, I think that wideband Keithley laboratory amplifier, I think that's going to have to go up here because that thing's really wide. So I'm going to need to move all this stuff up about that much. So that's probably going to have to set up there. And the other laboratory amplifier, the amplifier research one, will go over here on top of that, the AC isolation transformer variable power supply. So there you go. There's the progress so far. And new play toys are basically all, well, not play toys, of course they're tools. But yeah, when you work with this kind of stuff, it's always cool to get new play toys. But they're on the bench, everything's hooked up, and it's working. So, like I say, in the best way I can, like I said, I didn't want to go into in-depth. There's a lot of people, especially like Dave Jones, EEV blog, and a bunch of other people, done some really good in-depth, detailed coverage of what these things do and how well they do it. So, matter of fact, I watched their videos to see, I kind of used them as a guide to pick which models of stuff that I wanted. But, the best way I could probably, cover them is when I'm using them on the bench. If you don't hear me saying, this blankety blank piece of junk, as long as you don't hear me saying that when I'm using one of those things, well, I'm probably happy with it. If you hear me bitching at it, yeah, then we got problems. But from what I've played with it so far, or actually played with all 3 of them so far, I'm happy with them. They work great. So there you go. But like I say, just keep an eye out and see some of this new stuff in use.